Assalamu alaikum wa rahmatullahi wa barakatuh. Yeah, very good morning, students, and welcome to my channel Maths with Umar. This is the second video of grade 9 revision for annual, and the chapter is circles. Okay, so let us see now. I think the last time when in the first part I was explaining about theorem 9.7, right? What is theorem 9.7? It is that angle subtended by an angle subtended by an arc at the center is double the angle subtended at any other point at any point on the remaining part of the circle So what does this mean? So we have drawn diagram also. What was the diagram? Suppose this is a circle and it is a center. Let us take this arc AB and the angle subtended by this AB at the center. So at the center will be double the angle subtended at any other point on the circle. Let us say at this point the angle made by the arc, if it is x, so this angle will be 2x. So this is what we have to prove. Okay, so let us see what to prove. The first one to prove is, now join this point and center and extend it till any point which is D. Okay, so first line will be join PO and extend till D. Now please see that. So what is OP? What is OP? The line joining center and any point on the circle is radius. And in the same way, what is OB? OB is also the line joining from center to any point on the circle. So it is radius. So that means these two are radius. So now, what is this, my dear students? Is it a triangle? Okay, are you able to recognize, visualize a triangle? Say I'll draw the same here. Okay, this is the triangle and this is radius and this is radius. So what does that mean? So in isosceles triangle property, the angles which are opposite to equal sides are equal. That means what is opposite to this? This one. And what is opposite? Which angle is opposite to R? So this one. That means these two angles are equal. So are you able to understand this? So that means here which two angles are equal? This one and also this. Understood? So this will be the point first. Let us write down. So in triangle POB, OP is equal to OB. Is it right? What is the reason? Radius of same circle. Okay, and so that implies what will happen? Since OP and OB are equal, as we have seen here, these two angles are equal. So what is this angle? OBP. Angle OBP is equal to, what is this angle? OPB. So angle OPB. Okay, so let us take this as 1. Now what will happen? Now actually this side is extended till D, right? Let me extend this side till D. So now we have seen in grade 7 What is this angle? This angle is exterior angle, right? So what is exterior angle property? Exterior angle is equal to sum of opposite interior angles. Sum of opposite interior angles. So therefore, what is this angle? DOB. So now angle DOB equals, so what are the opposite angles to this? These two. Am I right? So it is angle OBP plus angle OPB. Is it right? This is second. Understood, my dear students? Everybody got it? Okay. Now, so here, since OBP and OPB are equal, these two are equal, can I write it as 2 angle OPB? Let us take this as second equation. Okay, 2 angle OPB. Angle DOB is equal to angle OPB. Now, in the same way, similarly, in triangle POA, which two are equal? OP and OA are equal. OP is equal to OA. So that implies, so which two angles are equal? What is this angle? Angle OPA. Angle OPA is equal to angle OAP. Okay, using the same concepts. And now let us take it as third equation. And after that, now what is this angle? This is exterior angle, and exterior angle is equal to sum of interior angles. So angle DOA. So angle DOA is equal to what are interior angles? Some opposite interior angles. These two are opposite interior angles. Angle OPA plus angle OAP. So since these two are equal, can I write this as 2 angle OPA? Because in place of OAP, I can write it as OPA. So OPA plus OPA, 2 angle OPA. Okay, this is fourth equation. Now what to do? Give me 1 second. Where are the tissues? Yeah, let me rub this. I hope you understood. So you also draw this diagram, then you will be able to understand it properly. So now what you do? You just add second and fourth. So now add second equation and fourth equation. So what will happen? What is second equation? Angle DOB is equal to 2 angle OPB. And what is fourth equation? Angle DOA equals 2 angle OPA. Got it? Now if I add these two, add left hand side, angle DOB plus angle DOA is equal to 2 angle OPB plus 2 angle OPA. So now DOB plus DOA, where is DOB? DOB is this and DOB is the red one. If I add these two, will it become angle BOA? So that implies angle BOA is equal to what? 2 is common. When I take 2 common, it will be angle OPB plus angle OPA. So what is OPB? OPB, that means the green one, and OPA is the red one. If I add these two, what is this angle? BPA. So that implies angle BOA is twice angle BPA. So what is angle BOA? What is this angle? This is the angle subtended by the arc at the center. So therefore angle subtended by arc at the center is, what is this? Double. What is angle BPA? BPA. It is the angle subtended at a point on remaining part of the circle. Remaining part of the circle. I hope now you understood how you prove the theorem 9.7. So theorem 9.7 is important because so many problems you'll in solving so many problems and proving the statements, you will be using this particular theorem. Okay, so please do along with me and also pause the video and do it by yourself, otherwise you will not understand these concepts. Okay, so mashallah, in when I try to correct the problems, when I try to correct the answer scripts of many students, they don't use the perfect steps. Okay, so please do not by heart the theorem, the proof of the theorem. See, statements you have to by heart, but proof of the theorems you don't by heart. Okay, you try to understand and repeat it. So let us see the next problems and pause the video and first practice it, otherwise you will forget. And mathematics is not about watching the videos, it is about doing. Okay, mathematics you cannot watch, you have to do it by yourself. So please do it. Okay, let us see the next theorems. So theorem 9.8 is angles in the same segment are equal. So what does it mean? So just now we have studied that, for example, the angle subtended by any arc, okay, at the center is double the angle subtended at any other part of the circle. Suppose let us say if this is 2x. So now tell me, what is the angle subtended at any other point on the circle? So this will be x, right? And in the same way you take anywhere, okay? So what is the angle subtended by the arc at this point? This will also be x. So now if I erase the angle subtended at the center, so what you can see, the angle subtended at any other points are equal. So he said segment. So when you draw a quad, okay, and accept that R, whatever is the area remaining in the circle is called as segment. So the angles in the segment, in the same segment, that means subtended by this arc or chord, are always equal. Understood? Remember this, because it will be these theorems will be useful to prove it. Okay, let us see the next theorem. So the next theorem, theorem 9.9, explains use the concept of concyclic. See, what is concyclic? In order to understand easily, I'll explain you. Suppose if you draw a circle and take any 4 points, anywhere on the circle, and if you join this 4 points on the circle, it will form a quadrilateral. Okay, so this quadrilateral is called as cyclic quadrilateral. This is called as cyclic quadrilateral. Okay, and the points, these 4 points are called as concyclic points. Understood? So these 4 points are called as concyclic points, and this is cyclic quadrilateral. Now let me explain you theorem 9.9. So theorem 9.9, what is theorem 9.9? You take any 2 points, okay, and join this line. So what is this actually? This is a line segment joining any 2 points. Okay, now what happens if if this line segment subtends an angle? Take any other point, I've taken here. So what is the angle subtended by it? Let us say it is x. Okay, let us say this point is B. Okay, now take any other point where the angle subtended should be same. Okay, so that means you take any other point here, for example. For example, you take, and this is x. Okay, if the line segment subtends equal angles at two other points, if the subtended angle should be same, okay, then if you join these 2 points, if join these 4 points, if you join these 4 points, the 4 points lie on a circle. Understood? This is the theorem 9.9. So what is theorem 9.9? If a line segment joining these 2 points subtends equal angles at 2 different points, subtend equal angles at 2 different points, and these 2 points should lie on the same side of the line. It is not that one point is here and one point is on the other side. Okay, so if they subtends equal angles at 2 other points on the same side, then the 4 points lie on a circle. This is theorem 9.9. Okay, my dear students. So now you understood what are concyclic points and also cyclic quadrilateral. Understood? So now let us see the next theorem. The next theorem is going to be a very important theorem. Okay, theorem. See, what does theorem 9.10 states? So theorem 9.10. So what does this theorem 9.10 states? So theorem 9.10 states that the opposite angles in a cyclic quadrilateral, are equal. Understood or not? The angles, the sum of either opposite angles. Understood? The sum of opposite angles in a cyclic quadrilateral are equal. Understood or not? So for example, let us say this is a cyclic quadrilateral. Okay, so when you add the opposite angles, let me say that this is A, B, C and D. So if you add A and C, so the sum of angle A plus angle C is equal to the sum of angle B and angle D. Angle B and angle D, and the sum is equal to 180 degrees. So that means if you add angle A and angle C, it will be 180 degrees. And angle B and angle D, it will be 180 degrees. Whether this quadrilateral, whether it is a quadrilateral, the quadrilateral formed inside the circle, whether it is a quadrilateral or a trapezium or or a parallelogram or a rectangle or a square, the sum of opposite angles will always be equal to 180 degrees. So which quadrilateral? It is cyclic quadrilateral. Understood or not? Only in cyclic quadrilateral. Otherwise, in normal quadrilaterals, we don't see this property. In normal quadrilaterals, which are quadrilaterals we will see? We see only in square and rectangle, right? Other than square and rectangle, we don't see this property, opposite angle. Sum of opposite angles is equal to 180 degrees. But if the quadrilateral is a cyclic quadrilateral, so that means cyclic quadrilateral means what? If the 4 points lie on the circle, then the sum will be 180 degrees. Understood, my dear students? So now with this we have completed the theorems. Now let us see the problems which I have explained, which I have given for worksheet, as a worksheet. Okay, let me pause it and open the questions.